There is one supplier who never rests. With more than 500 researchers and 4,000 valid patents, we are always on the move to increase our customers' profitability. This film will show some of our latest innovative breakthroughs. Metso Panel Board is a part of Metso, a worldwide plant and process supplier with machinery for the minerals, pulp, paper and panel board industries. Metso Panel Board is a leading supplier of engineering know-how and technology for complete lines to produce MDF, particle board and OSB. Our long-term commitment to being a supplier of complete lines is supported by a long history of innovation. The name Metso Panel Board embodies such brands as Sunds Defibrator, Kvarner Panel System, formerly known as Bisonwerker, Farney Engineering, Flecht Fiber Dryers, and the Kusters Press Division. These companies are now Metso Panel Board. Metso Panel Board supplies everything a panel board producer needs, from wood yard to finishing line. We have everything, all under one roof. Our lines combine custom-tailored and modular solutions to provide customers with the most profitable investment. We supply environmentally sound lines that reduce production cost while increasing production efficiency, capacity, and panel quality. This is Hallein, close to Salzburg in Austria. The Austrian company Binder Holz and the German Fleiderer have made a joint venture, the Mdf Hallein factory. The factory is designed for 160,000 cubic meters per year. The factory is close to the surrounding towns and tourist resorts. Hence, the operations in Mdf Hallein face maybe the toughest environmental regulations in Europe. Metso Panel Board is the main supplier. The wood yard is a downsized version of those which Metso supplies for the world's paper and pulp industries. The raw material is mostly spruce. It consists mainly of waste from Binder Holz and Fleiderer's own mill operations. The chips are screened in the highly efficient Classy screen. Oversized material is separated. The chips are washed in a chip washer. Care is taken in the design so that no unnecessary water is added. This reduces the dimension of the water purifying plant. The chips are conveyed to the steam bin, down to the screw feeder and into the preheater. The defibrator is an M54. The compact size is deceptive. It has 70 tons of axial thrust that puts real muscle at the heart of the MDF process. Mdf Hallein uses the Metso resin and wax system. It's a reliable design in stainless steel, made to last. Extensive efforts have been taken in order to build an environmentally friendly plant. The two-stage flue gas heated dryer is therefore equipped with fiber conditioning and RAS, return air system. Equipment such as the Z sifter has been located indoors. The advantage is an even temperature and reduction of possible noise to the factory surroundings. Mdf Hallein uses an active former, the uniformer. The bin is constructed with plywood walls that provide insulation and reduce the risk of condensation. The wooden walls also reduce the risk of static fiber clinging to the walls. Under the outlet of the forming head, there's a 4-meter-long scale. Its long length and sophisticated electronics ensure an accurate signal for the discharge rate of the dosing bin. The discharge rate is controlled by a variable speed drive unit which operates the bottom feed belt. The fiber is discharged down to the forming unit. The roller bed compacts the fiber mat by 10 to 20%, This, in combination with the mechanical treatment, gives a mat with a good structural integrity. The forming accuracy is better than plus or minus 2% lengthwise and crosswise. The roller bed is automatically tilted in such a way that the height of the first or lowest roller is set in a selected ratio to the height of the last roller, and the desired panel density selected by the operator. The width of the mat can be adjusted by 600 mm or 2 feet. The adjustment takes place within the former. On both sides of the forming lineup to the pre-press there are sidewalls. These sidewalls can be moved simultaneously into the former. But how does this affect the forming rollers? The outer parts of all forming rollers are fitted to the shafts with a telescope arrangement, which means that the parts are moved closer to each other as the walls are moved inward. Inside the forming bed, there's a screw arrangement across the former. At both ends of this screw, there are two movable funnel-shaped inlets that are moved inwards together with the sidewalls. The function of these funnels is to collect the fiber from outside the sidewalls when forming a narrow fiber mat. The fiber is then distributed into the reduced forming width and, which is very important, without being recirculated into the forming system. The additional benefits include better quality of the resonated fiber, because it doesn't have to be mixed with recirculated and maybe already hardened fibers. This means better quality of the resonated fiber and reduced resin consumption. Uniform fiber moisture content, low power consumption, reduced costs in pneumatic conveying systems because the mat is not scalped. The pre-compressor is built on a multi-nip principle and a double belt concept. Mdf Hallein's 28-meter Custos press is not the very latest design today available from Metso, but it's a good example of how we implement new solutions into existing machinery design. Due to a new chain design, the press can work with the variable mat forming width created by the uniformer. The new chain design facilitates wider press lines with up to 12 feet. The fact that the rollers in the chain are only 12.5 millimeters in diameter means that there's a very large area of surface contact of the chains with the steel belt and the heating platen. This in turn gives very efficient heat transfer, meaning that the temperature difference between the heating platen and the belt surface is very low. This efficient heat transfer means that lower heating oil temperatures can be used. Another important and advantageous feature has recently been added to the Custos press: the cooling zone. It brings down the temperature and therefore the steam pressure in the board. This sharply reduces the risk of board blisters or blown board, and it increases the press factor with up to 20%. The cooling zone is accomplished by the use of two separate chain runs. The normal hot chain supports about 70 to 80% of the press, and the final cooling chain supports the final 20 to 30% of the press. Since the diameter of the rollers in the chains is only 12.5 millimeters, the chain run can turn through a tight radius, so that the gap between the hot chain and the cooling chain runs is minimized. This gap width is very important since it keeps the area where the board is not supported to a very minimum. Another important advantage of the cooling system is the ability to run the board at higher final moisture content as it exits the press. In a conventional press, the moisture content is not uniform through the thickness of the board. The average moisture content may be 6%, but there's a wide variation between the surface and the middle. The cooling zone concept from Metso gives a more uniform moisture profile through the thickness of the board and allows the board to exit with a defined and, if desired, higher average moisture content of 7 to 8%. This level of moisture is close to the equilibrium moisture content in many parts of the world, and it means less chance of warping and a shorter conditioning time after the press. The new cooling zone also offers the possibility for energy savings from 10 to 20% in total heating costs, since the heat can be recovered. In general, oil in the cooling zone can be around, as here in Hallein, 80 to 90 degrees Celsius, while the hot zone is much warmer at 200 to 220 degrees Celsius. Mdf Hallein uses this advantage. The oil from the cooling zone passes through a heat exchanger. The recovered energy is then used for preheating the primary and secondary air for the combustion chamber. This means energy savings, savings in raw material, reduced emissions, and increased production capacity. It's also worth noting that the lower exit temperature will reduce the risk of fire. The intermediate storage at Mdf Hallein is supported by the Lucky storage system. As you can see, it's the new design where the panel stack is lifted higher than before. This means reduction of square meters for intermediate storage or a higher storage capacity. The energy plant at Mdf Hallein differs from more traditional installations. The energy plant is indoors, which means noise reduction. It's another example of the extensive efforts taken in order to build an environmentally friendly plant. The building also makes it possible to recover surplus heat. The air is used in the mixing chamber, which means both better cost performance and better working environment. The heat energy for the plant, comprising steam for the refiner system, flue gas for the dryer, and hot oil for the press, is produced in a 42 megawatt solid fuel combustion chamber. It takes skill and a good portion of courage to invest in new technique. The calculation for the cooling zone turned out to be even better than anyone expected. The line is designed for 160,000 cubic meters per year. Due to highly skilled operators and innovative technique, that capacity has been exceeded by a wide margin. The control system makes the line very manageable. It takes the operators 6 minutes to change production from one thickness to another. Mdf Hallein has an extremely high availability of the line. They don't want to go public with any figures, but can disclose that they are very satisfied with the results. As a supplier, Metso Panelboard's responsibility is to develop more efficient processes and machines to ensure that our customers can stay ahead of the cost curve.